Imagine stepping inside a time machine, not to visit next year or even the next millennium, but to travel farther into the future than any human mind can truly grasp. Picture setting the dial forward not by billions, not by trillions, but by 10 billion years. That's the one with 19 zeros after it. In that distant era, the universe will look nothing like the brilliant star-filled cosmos we know today. So what would you see if you could witness the farthest reaches of time? Let's take that unimaginable journey. First, a reminder of scale. 1,000,000 years is already beyond the span of human history. 1,000,000,000 years is longer than complex life has existed on Earth. But 1,000,000,000,000 years is 1,000,000 times a trillion. Even stars, galaxies, and black holes are fleeting when measured against such enormous numbers. If we fast forward just a few billion years from now, our sun runs out of fuel. It swells into a red giant, engulfing Mercury and Venus and likely turning Earth into a scorched, uninhabitable wasteland. After that fiery death, the sun collapses into a white dwarf, a dense, cooling ember of what was once a shining star. By then, humanity, if it still exists, will have long left Earth behind. Push forward another trillion years, and galaxies as we know them begin to fade. No new stars are being born because the hydrogen fuel they require is gone. The great stellar cities of the universe slowly shut down. The Milky Way, long since merged with Andromeda into the massive Milkomeda galaxy, will be filled only with aging stars, brown dwarfs, neutron stars, black holes, and countless planets orbiting these dead suns. For a while, occasional collisions between these remnants will create fleeting bursts of energy, but these fireworks grow rarer and rarer with time. Now let's leap ahead to 10 quintillion years. By then, nearly all stars and stellar remnants will have been ejected from their galaxies, nudged out over eons by gravitational interactions. Studies suggest that by this point, around 99% of what were once stars will be drifting alone in the vast cosmic void, separated by distances so huge that for most of them, they'll never encounter another object again. Galaxies themselves will no longer shine, and the very concept of a night sky filled with stars will be ancient history. This is what physicists call the degenerate era, a time when the universe is dominated not by glowing stars, but by the corpses they left behind. White dwarfs will cool into black dwarfs, frozen spheres radiating no light at all. Neutron stars will persist as dense, invisible husks. Black holes, scattered across the cosmos, will quietly distort space around them, swallowing anything unlucky enough to drift too close. Occasionally, two of these ancient remnants might collide, releasing a flash of energy. But such events are so rare that you could wait longer than the current age of the universe just to see one. Meanwhile, the expansion of the universe continues to accelerate. Driven by dark energy, galaxies move farther and farther apart, until their light is stretched beyond detectability. To any observer living in this far future, the universe will appear almost completely empty. The cosmic microwave background, that faint afterglow of the Big Bang we can detect today, will by then be stretched into wavelengths longer than the size of the observable universe itself. In other words, the echo of the Big Bang will vanish. The history of the cosmos will be hidden from view. And yet, the story doesn't end here. On timescales beyond even 10 quintillion years, the universe may face one of several fates. In the Big Freeze scenario, expansion continues forever, and the cosmos grows colder and darker, approaching absolute zero. In the Big Crunch, expansion reverses, and everything collapses back into a singularity. Some models predict a Big Rip, where dark energy becomes so powerful, it tears galaxies, stars, planets, and even atoms apart. Or there could be something stranger still, new physics, new dimensions, perhaps even a rebirth of the universe in a cycle of death and creation. By 10 quintillion years, the universe will already be almost unrecognizable. No stars, no galaxies, no planets with oceans or life. Just black dwarfs, neutron stars, and black holes, drifting endlessly in an ever-expanding void. Think about that. Right now, when we look up at the night sky, we see countless stars scattered across the heavens. But that view is temporary. The stars themselves are temporary. Our entire galaxy, glowing with hundreds of billions of suns, is just a fleeting flicker in cosmic history. And so, what does this mean for us? It means that our moment, right now, is extraordinary. We live in a universe still bursting with light, with energy, with possibility. A cosmos filled with galaxies, nebulae, planets, and life. A universe still young enough that stars shine brightly, but old enough to have produced creatures like us who can wonder about its fate. When you gaze at the stars tonight, remember, they are not eternal. They are brief sparks in a vast, unfolding story that will one day grow silent. But in that silence, in that incomprehensible future, lies the reminder that our present is precious. We live at a time when the universe is alive with brilliance, and that makes this moment, right here and now, all the more meaningful.